This illustration deals with AC systems of 50 volts to 1,000 volts. NEC 220B informational note. Before we get started with 250, I'd like to point out to the users of the NEC that you ground these systems by 250.20B as in boy, and if you use the grounded conductor, you ground the transformer is outlined there in that section. Then you must bring the grounded conductor to the service equipment. However, you could go over and review 250.21 and you have a choice. You can either ground the transformer or you don't have to ground it in that manner. If you go over to 250.22, then you cannot ground the transformer and it is listed there. You know, you'd use an isolation transformer or type transformer that would comply with 250.22. Now, with that thought in mind, you have to select an electrode system. So 250.50 of the code says that the grounding electrode system, if you have more than one electrode, you bond them together to create a grounding electrode system. 250.52 describes to the user of the NEC what could be used as a grounding electrode. 250.53 is usually what the electrician used to install the grounding electrode system. So kind of keep those 6 sections in mind when you start grounding. Now, first of all, I would like to look at the transformer in the illustration, and you have to ground it. Now, if it's a utility ground, they will ground it in accordance with Article 90 of the National Electrical Safety Code. But if it happened to be a transformer that was customer-owned, then it would be grounded usually by 250.30 if it had an overcurrent device ahead of the primary conductors feeding it. So with that thought in mind, we have decided now, secondly, to look at the grounding procedure of this transformer. Now notice, looking in the illustration, you have a grounding impedance listed there. And the designer is grounding the transformer, the high impedance grounding system. Now notice, if you look at the note, which I'm going to go ahead and review at this point, we are told that if we would review Annex 0 to NFPA 70E, then high impedance grounding provides an effective tool to reduce arc flash hazards, which we will talk about a little later into the program. But then notice we ground the transformer here with a driven rod, or if you had say a foundation ground instead of just a pedestal, you could ground to that if it meant, 250.52 for a concrete encased electrode. Now notice at the service equipment inside the building, if you notice there that we don't ground it there, so we don't get any nuisance backfeed, that the high impedance ground just wouldn't function properly in many cases. So the designer would look at that. Then notice the building still is effective earth grounded by 250.52A2. When you look at the SBS is earth grounded, that arrow pointing to the structural steel. And then, of course, if you look at the final thing at the service, and you can see that the grounded conductor coming in is isolated there for purposes that I just outlined to you. Now, 250.36F is in fun. That deals with 1,000 volts or less when you're high impedance grounding. 250.187 deals with impedance grounding when the voltage is over 1,000 volts to ground. Now, the main purpose of change here was to provide a new informational note, and it was added to emphasize that high impedance grounding is an effective tool to reduce the arc flash level of energy at a given point where a ground fault, short circuit, etc. could occur.